Welcome to Study Loop.
This is the answer to Chapter 21, problem number 92 from the Smith Organic Chemistry textbook. And this problem is asking us to draw a stepwise mechanism for this reaction that's pictured in the problem. So it's basically going to be just an SN2 displacement of bromide followed by intramolecular enamine formation. So the first thing that's going to happen is carbonate is going to grab this hydrogen, and the electrons will go to the nitrogen there. Oof. So that's going to get us to here. And then the next step is going to be, so let's see, how do I want to draw this? So rather than draw this entire large molecule, most of which is not participating in the reaction at all, what I'm going to do is I'm going to use a squiggly line notation to show that there's a ring, really a system of rings over there. And I'm just going to draw the parts of these molecules that are actually participating in these reactions, because it's really a waste of time and effort to draw an entire large multi-ringed molecule that is not doing anything in this reaction. So this nitrogen is going to add into this carbon, which is going to push these electrons to act as a nucleophile and attack that carbon. And the bromine is going to leave. So that is an SN2 reaction. The product of that reaction is going to be this. So again, this squiggly line shows that these are connected by a ring. There's a positive charge on this nitrogen. It has 4 bonds. And so carbonate ion is still floating around in here, 2 minus. That's going to come and take this proton. These electrons are going to go here to form a new double bond. One of these bonds will break. And that's going to get us to this intermediate. And so from here, the lone pair on this nitrogen is now going to act as a nucleophile and attack the carbonyl here. Those electrons will kick up to the oxygen. Product of this reaction is formation of a new ring here. So that's going to look like this. Nope. There we go. So that's going to look like this. This oxygen will have a negative charge in 3 lone pairs. This nitrogen obviously has a positive charge on it. It has 4 bonds. And so, by way of a proton transfer, we can get to the uncharged species. And then we can invoke just any generic acid, HA. One of the lone pairs on this oxygen. Did I forget a hydrogen? I did forget a hydrogen. Oh no. There we go. One of the lone pairs on this oxygen can grab that hydrogen from the HA. Once that happens, we will get to this intermediate. And I am going to draw this proton in here. So now this oxygen is going to have a plus charge on it. This bond will break and the oxygen will leave. And at the same time that that is going on, we can use more carbonate ion. Oops. We can use more carbonate ion here to grab that hydrogen, and those electrons can go to form the double bond there as that water is leaving. And so that is going to get us to our final product. So double bond there. And then, of course, the entire rest of this pretty sizable molecule down there. I didn't draw it. I would advocate not drawing it if you don't have to. So it's in addition. So we just made a ring, and then there were 1, 2, 3, 4, 5 other rings linked together in this molecule. It's senseless to draw each of those rings every single time, unless they're participating in the reaction in some way, and in this case they weren't. So I just drew the portion of the molecule that's actually undergoing a reaction here. And this is the mechanism. Again, it's an SN2 displacement of bromine followed by intramolecular enamine formation. And here it is. And that's the answer to chapter 21, problem number 92.